sharing my screen. Let me know if it is visible or not. My screen is visible? Okay.
Yes, ma'am.
Thank you. 27 students, let's wait. Let's wait for 3 more minutes. Okay. So, what we have discussed so far, basically, determinate and indeterminate structures, right? And you have with you 3 equations of equilibrium, which is this f of x. Screen is visible? Screen is visible? My screen is visible?
Yes,
Yes,
ma'am.
ma'am.
Okay. So, we have discussed f of x equals to 0. These are the 3 equilibrium equations. Okay. Now, let's come to a point where it is your you have to differentiate between statically determinate structure and statically indeterminate structures, right? So see, these was you should know for roller you should take there will be one reaction vertical. For pin or hinge there will be 2 reactions, vertical and horizontal, and for fixed you will have 3 reactions, vertical, horizontal, along with movement. Okay, see this beam, you have this beam which is supported. This beam is supported on a hinge support and one is roller support, right? So if you want to draw a free body diagram of this, so the diagram will be like somewhat this. Yes or no? This will be the reactions of this free body diagram of this beam with this, with all the reactions. So for this beam, we have unknown reactions as 3. How? Let me note once again. Let me take a red color. Many are left. Many of you left the meeting. I don't know why. Okay, so this hinge support will have a reaction like this. Suppose I'm taking S, it is X, Rx. Okay, and it will have a horizontal reaction which is of Ry. Again, it will this roller support have a reaction of Rx1. Suppose this is Rx and this is Rx1, and this will have Ry. So we have how many unknown reactions? We don't know Rx1, Rx, and Ry. We have 3 unknown reactions, that is 3. And what are the equation of equilibrium we have? Summation of Fx equals to 0, summation of Fy equals to 0, this is summation, and summation of M equals to 0, right? So number unknown reaction is 3. In the same way, unknown equation of equilibrium is 3. So we can find these 3 reactions by these 3 equilibrium equations. So this is statically determinate structure. Okay. Why it is called statically determinate structure? Because we have 3 equilibrium equation and all the known reactions. As we have the definition, to go back to the definition, a structure for which all the unknown reactions can be determined using the equations of equilibrium. Whatever be the unknown reactions, all can be determined by equation of equilibrium. That will be referred as determinate structure. Now come to the indeterminate structure, which is this one. Suppose I have a beam where beam is supported on 2 hinge points. So what are the reactions for this beam? There will be one Rx. Suppose I am giving it 1 Rx1, and this one I'm giving as ry, reaction in y direction 1. Same for this hinge position, we have two directions. One is this one, another is this one. I'm naming it as ry2, sorry, rx2. This will be here ry2. This is rx2. So what are the unknown reactions we have? 1, 2, 3 and 4. We have unknown reaction as 4. And number of equilibrium equation we have 3. So we'll need another equation to define or to solve this, to get this reactions for this structure. So this structure will be defined as indeterminate structures. Okay, understood or not? Am I clear? The basic difference between statically determinate and indeterminate structure. Am I clear?
Yes, ma'am.
Okay. So for this,
Yes, ma'am.
for the first section, for the first module, we'll just study statically determinate structures. Okay, and we'll see the analysis of truss under this section. Again, I want to again explain this statically determinate and indeterminate with one more example. Suppose I have a beam which is fixed, and you know for the fixed you have three conditions. One will be vertical, and one will be horizontal, and another it will be a movement, right? For a fixed beam you have three reactions: vertical, horizontal and this. And for this beam also, this is also fixed beam. Generally in our civil engineering structures, all the beams are, maximum structures are in fixed position. If you go and notice, maximum structures are in fixed position. So it will have fixed reactions, right? So one, this is, suppose I'm taking Rx1, Rx2, Ry1, Ry2, Rm1, Rm2. So number of reaction is 6 and we have only 3 equations. So it will be insufficient to solve these, to get this unknown from this only 3 equations. So we will need more equations to solve the rest of the reactions. So this is also an example of indeterminate structure. Okay, and you may have a question, or I don't know, no one asked me why we need this, why a structure needs these three equations to get a stable structure. Means why these three equations are needed? Only why we don't need two conditions for a beam to a for beam or a structure to stable. See, suppose I'm taking a hinge point here. Okay, suppose I have a beam with, suppose, let's take this example of this. See, suppose here I have this two forces. Okay, this will resist. Suppose forget about this pin. This is a roller support. Okay, suppose you have here roller support. Okay, so it will have only vertical direction, right? Again here it will resist only vertical direction. When I applied a load on this structure, right? When this is the vertical direction, we have only vertical direction. Suppose I applied a load in this direction, so this structure will move to this direction. So to resist the movement of this in this direction, understood? We have roller support on a beam and I am applying a horizontal force to a beam. So this structure will move to it will shift to a new place. But if we provide a support which will resist this horizontal movement, then there will not be movement. So we need this horizontal reaction also. Again, I have this horizontal and vertical reaction resisting this pin is resisting this horizontal and vertical movement. What if I am twisting this beam? Then it will show a movement or not. Then again, if I put a fixed support, then it will resist the motion also. Then your structure will become stiff. It won't go vertical. It won't move horizontal, and it won't move. Won't rotate also. So So that's why we need these three equations. When these three equations satisfy, your structure is called stable. Hope this point is clear why we need these three equations basically. Okay. So in this section will study the analysis of statically determinate truss. So you have understood the part of statically determinate. Then let's move to the part of truss. Okay. Let's move to the part of truss. So basically, a truss is a structure. Can you, ma'am, please explain once again which part you are asking? Why we need three equations? Okay. Yes, I can explain. Suppose I have a beam. Let me note the next. Suppose I have a beam which is having only roller support. Okay, I have a beam which has only roller support. So for the roller support, it will only resist your vertical reactions. It will only give you vertical reactions. Okay, and if I put a horizontal force on this member, this beam will move to a new position or not? It will move. I've applied a load on this direction, it will move to this direction, right? It will move to this new direction. So to resist this movement, what we do? We provide a pinpoint, because pinpoint we provide a pinpoint or pin hinge joint. Hinge joint. So what the purpose of hinge joint? What are the forces it resists? It resists vertical forces and it horizontal forces. The now we need y and we need x also. These two equations, x and y. What will happen if I try to rotate it? It will rotate or not? Right? It will rotate. But to overcome this rotate, what we do? We provide a fixed beam. What happens in fixed beam? It will resist your vertical direction also. It will resist its horizontal direction also. Again, it will resist your movement or rotational movement also. So it is stiff from all the directions, so it will be more stable. So that's why we need Rx, reaction in x direction, reaction in y direction, and movement, reaction against movement. All the movement, all the reaction Rx equals to Rm equals to M equals to 0. Summation of all the reactions should be 0. Am I audible? You lost your voice. At what point you lost my voice?
Mm,
Hinge point.
in,
Now it is clear? My voice is clear?
yes, ma'am.
Let's move to the next part. Please see the recording if you don't mind.
Okay.
Okay. Because I have to complete this section also. If I have time at the end of the section, I'll again explain why we need what is the need of that three. So we'll discuss truss. So basically, what is truss? You generally see the truss in the steel bridges, maximum steel structures, steel frames, steel warehouse. So it is a structure composed of slender member. What is slender member? Two force member. Okay, where a member which will have two forces jointed together at their end points to support stationary or moving load. So a truss member is jointed. Okay, this is your truss member. It is jointed to a end point. This is a member. It is jointed at this point. Again, it is jointed at this point. It is jointed at this point. So just take the example. This is a truss member. It is jointed at this point. It is jointed at this point. Again, it is jointed at this point. Again, jointed at this point. Okay. So calculation are usually based on following assumptions. In the truss, we generally take some assumption. What are those assumptions? We have joints. The loads and reactions act only at the joints. So in the truss analysis, this is very important point. The loads and reactions act only at the joints. At joints, all the loads there will be acting, and the reactions will also be taken at only joints. Weight of the individual members can be neglected. In analysis of trusses, we generally neglect the weight of the truss. What is the weight of this member? What is the weight of this member? We generally neglect that part. And members are either under tension or compression. As I discussed, truss in truss, axial forces or maximum axial forces are acted on truss. So axial forces either tension or compression. We have discussed, right? Tension and compression. And these joints are usually formed by bolting or welding the members. So this is one joint welded. This is one member. This is one member. This is there has been a this member and this member has been joined by a welding. Okay, this is the gusset plate. You will get it in higher classes. This is the gusset plate. So these two members have been jointed by welding. Okay, these are usually formed by bolting. Bolting means they have provided some screw, some points. If you see the Brahmaputra Saraighat bridge, that is a truss bridge, right? The first one, not the new one. The first one was a truss bridge. If you see closely, you will see this type of pattern. So the members are bolted. Some screw have been used to join those members to a plate, and this is the one another member. So these members are joined by a these members are jointed by either bolting or welding the members to a common plate called a gusset plate, or simply passing a large bolt through each member. Okay, so your structures now you have to see when the structure is statically determinate. I mean, you have to see a structure when it is externally, or a structure should be externally stable and internally also. Okay, suppose, see, this is the structure. It is in pinned position. Okay, but when you apply a load on the midpoint, see, it externally it is stable. Okay, you have externally this structure will be stable, but internally it won't be stable. So you have to see when the structure is externally stable and internally not stable. So you have to see the structure should be externally and internally both way it should be stable. So basically analysis structure is classified like this. You have to analyze the external equilibrium also and internal equilibrium also. To check the external equilibrium, you have to find the reaction forces. Okay, and to internal equilibrium, to find the forces in the members, you have to find the forces. What are the forces acting on those members? So we have two methods how to find the forces in the each member. We have two methods: method of joints and method of sections. Just tell me, have you gone through this in engineering mechanics? Have this part have been discussed in engineering mechanics? Respond. Hello.
Ma'am, which part?
This analysis.
Even if it is, we forgot.
If it is, you forgot. Fine, I'll explain. But
Method of.
Ma'am, we forgot. Yeah.
yes.
I don't think we discussed.
Okay.
Yeah, I don't think so.
Okay.
Even if it is, yeah.
Okay. Okay. No. Don't worry. I won't. It's not like that. I won't discuss. I won't. I will discuss. But I was just clearing that you have some clearance or not about those points, like number of joints, number of members. Anyway, let it be. So we have to analyze this truss. We have external equilibrium and internal equilibrium. So how to determine the external equilibrium? You have to find the reaction forces. And for the internal equilibrium, you have to find the forces in each member. And there is a two methods: method of joints and method of sections. We'll discuss these two methods further. So let's see. Let's start with external equilibrium. Okay, how to find the reaction forces? So to find the reaction forces, these are the steps. What you have to do? You have to first draw the free body diagram of the entire truss. Whatever the truss is given to you, you have to first draw the free body diagram. Then you have to determine the reactions using equations which state f of x equals to 0, f of y equals to 0, and moment about a point equals to 0. Okay, this is the stress given to you. This is the free body diagram. Okay, it has joints A, C, and B. A, C, and B. It is pin joint, so it will have AX, AY. Okay, this is the roller joint, so it will have only vertical direction. And one load is applied to it, which is 500 Newton. So this is your truss. This is the free body diagram. So let's start with method of joints. So to find the forces in any members, choose a joint. Okay, you have to choose a joint to which that member is connected and follow the below process. What you have to do to find the forces in any member, whatever be the member of that, suppose this member, you have to find the forces in this member. So choose a joint. What are the joints attached to this member? This member and this member, this joint, right? You have to choose a joint to which the member is connected and follow the below steps. So what is the below step? Let me remove this part. Just wait a minute. Okay. So what you have to do, you have to draw the free body diagram of the entire truss, which is the first step in analyzing your truss. So this is the truss given to you. It has a point of roller support, and this is your pin support. This is A, B, C, D. Okay, and there is one load is acting at D point. So you have to draw a free body diagram, which is this is your free body diagram. For pin position, you have AX, AY, and for roller section, you have only CY. And these are the distance given. A load is acting on it, and these are the distances given to you. Okay. Determine the reactions using the equations which state this. Choose the joint and draw free body diagram of a joint. Again, suppose you have to choose a joint A. So you have to draw the free body diagram of the joint A. Okay. Draw the free body diagram of joint with at least one known force. You should know at least one known force on that member to and at most two unknown forces. You have to choose a joint where you know one unknown forces, or at least one known forces, and at most two unknown forces. Okay, you have to choose the joint in the way that first draw the free body diagram of that joint with at least one known force and at most two unknown force. Then using the equation, find the internal forces. Again, let's move to the another joint. Suppose this is the A joint. Okay, the A joint is this one. If you draw a free body diagram of this is in 90-degree position. Okay, this is probably 45 degree. So this will be FAB, and this is FAD. Here, ma'am, please unlock the meeting. Some has lost network. Okay, let me unlock. You are in the waiting list. Unlock meeting. So I have unlocked the meeting. Tell them to join again. I have unlocked the meeting. Just wait a minute. I'm unable to unlock the meeting. Ask them to join. I'll allow them from the waiting lobby. Okay. So for the D, they have joined. They have drawn a free body diagram. This is the free body diagram. They have given this from here to here. There is 1/4. That is, 1 is vertical and 4 is horizontal. A slope is given to you. Then in this part, from here to here, they have given 3/4. So you have to analyze that joint based on your dimensions given to you. Then you have to find the reactions on those joints. Okay. That's how you have to find it. You'll understand when we'll do the numerical. So this is the basic procedure. What you have to do, you have to draw a free body diagram of the entire structure. determine the reactions. You have to determine the reactions on those points. Then you have to choose a joint in a similar way that at least one there you know the one known forces and at most two unknown forces. Then, ma'am, in joint B, what is known forces? The P value will be given to you, na? This is the external force, right? P value will be given to you. They have applied a load on that member D, so it will be given to you. So on D member, you will know the P value. Then you have to find the other forces. You'll understand when you do the numerical, but this is the procedure. Okay. Method of section we'll discuss later on, or should I discuss now? Okay, let me discuss now. So in method of earlier you take a particular joint. Okay, now now you need to take a section. To find the forces in any member, choose a section to which the member is appeared as an internal force and follow the below steps. Same way you have to draw free body. This is the truss. You have drawn the free body diagram. Okay. And found by drawing the free body diagram, you have to find the reactions. AX, AY, DY. Okay. How will you find? See, if you equate the vertical forces, summation of vertical forces, what will be? AY plus DY equals to 200. AX equals to directly this AX will be equal to this 400 or not? Summation of summation of horizontal forces. So AX, this is your AX. I'm taking this direction as positive, so this direction will be negative. Minus 400 equals to 0. Equals to 0. So what will be your AX? If this minus 400 comes to this part, so your AX will be 400. Yes or no? Let me allow this.
400.
Huh? It will be 400 or not? So first, what you have to draw? What you have to do? You have to draw free body diagram of this structure. Then you have to find these reactions from the load given to you. After you find the reactions from this, you have to take in earlier section you have to take a joint. Now you have to you have to take a section on which your on the जहाँ पे member find जिस member का force निकालने के लिए बोला, you have to take that a section. Okay, choose a section and draw a free body diagram of that section. Shows how the force replace the sectional member. Again, these are the steps. Suppose you have been asked to find the force on this member. Suppose I have taken a member of this. This is the member they have taken. This FGE. This will be FGE. This is the G. The force in this member will be FGE. The force in this member will be FGC. And the force in this member will be FBC. Right? So these are the, we'll understand when you do the numerical, but you should know the points also. What are the procedure? First, you have to draw a free body diagram of the stress given to you. Then you have to find the reactions for the force given to you. Then you have to take a member or a joint on which you have been asked to find the forces. We'll discuss this part later on after we completed this method of joints and method of this. So analysis of stress zero force member. So analysis of stress system is simplified if one can identify those members that support no load. Okay, the analysis becomes easy when you can identify those members that support no load. There are certain members in the structure which doesn't carry any load, and we call these as zero force member. Okay, suppose if two members form a truss joint. Suppose these two members form a truss joint A, and there is no external load or support reaction at that joint. See, this is the member. There is no external load and support reactions. Okay, then those members are zero force members. See, at this joint there is no force. Yes or no? This is one member. This is one member. It is joined by a point A. Here, no external load is applied to this member, and no support reactions are given to this. So these FAF or FAB are zero force members. Okay, summation of x equal to 0, so f of AB is equal to 0. Summation of fy equals to 0, so f AF is equals to 0. Joints D and A in the following figure are the joints with no external load or support reaction. So joint D is this. This is the joint D. Let me note. This is your joint D where no external at this point no external load is applied to this point and there is no support at this point. Are you able to see? There is no support or external load at this joint, so it will be your zero force member. Again, this is the point. No force and no external load is applied to this point, so this is your zero force member. Okay. So FAF. So force at A to the F and force A to the B and FDE and FDC will equals to 0. Okay. These they have shown. Then these are the more examples of the zero force members. Here in the following figure AC and AD, this AC yani C joint and AD yani your C and D joints are zero force members. So the force in this and this direction will be 0. C to A, not A to C, huh? C to A and D to A. Force in this member C to A and D to A will be 0. This is the example. Shall we have time? Let's discuss these questions in the next class, okay? Let's do these examples in the next class. Till then, go through whatever we have studied today. What are the zero force members? Method of sections, method of joints, okay? Then this statically determinate structures, indeterminate structures, idealized structure, unstable structures. Hope today's class so far is clear to you all. We'll do numerical in the next class, fully on method of joints. Okay, we'll do numerical truss analysis of truss, fully on method of joints. We'll do 2-3 numericals on method of joints and then we'll move forward to method of sections. Is it okay? Is it okay? Please respond.
Ma'am.
Yes, ma'am.
Okay, okay. Write your roll numbers in the chat box and stop sharing my screen. Okay. Write your roll numbers in your chat box and don't leave the class until I say. Someone is coming in the class now. Don't leave the class, okay, until I say, because it won't appear in the participant list. All of you wrote their roll number. Is anyone left to write their roll number? Let me mark. Okay, hope everyone wrote their roll number. Okay, I'm ending the meeting.